In this video, we're going to learn how to name acids. Acids are compounds that, when dissolved in water, they increase the concentration of H plus ions, so hydrogen ions. So for example, if I were to put, let's say, some hydrochloric acid in water, HClAQ, we'll go over this formula in a second, it would ionize. So basically it means come apart. Not really, I'm just simplifying right now. But the H and the Cl would separate to form some H plus and some Cl minus. Again, this is a simplified idea of the concept, but the general idea is that acids increase the concentration of H plus when they're dissolved in solution. That being said, when you have an acid, typically when you have a compound that starts with an H. Not all the time, but in most cases. And so you need to pay careful attention to the formula to realize if you have an acid or not. So here we can see some common examples of acids. You'll notice that these acids here start with an H and end with a non-metal like F, Cl, Br, I. These are called binary acids. Binary acids are acids that are made up of two elements. One is H and the other is a non-metal element. Now, you'll also notice that the acid has AQ next to it. AQ means aqueous, dissolved in water. So if you're going to be calling something an acid, you need to make sure that you see that AQ sign next to it, meaning dissolved in water. If it's not dissolved in water, then you can't call it the acid, because really an acid can only act as an acid by being dissolved in water. That's where it increases the H plus concentration. If you just have HFG, so HF gas, that's hydrogen fluoride. But once you put it in water and it dissolves, then you can call it hydrofluoric acid. So there's two main types of acids that we'll be seeing. We'll be seeing binary acids, which have two elements in it, H and a nonmetal, and then something called oxyacids, and they have H and usually a polyatomic ion containing O in it. So in this video, we're going to focus on binary acid naming and formula writing. In the next video, we'll study oxyacids. So we'll start off by learning how to name a binary acid. So let's say, for example, we want to name HF as an acid, so it's AQ, dissolved in water. The first thing all binary acids have is the prefix hydro. And the main reason is because hydrogen is a star of the show. Hydro. Then you take a look at the element that it's connected to. This element here, you know, is fluorine. And what you do is you replace the ending of the element by ic. So here we have hydrofluoric, one word. And then finally at the end, to indicate it's an acid, you put the word acid. So we have hydrofluoric acid. And you can see the same concept applies to all of these ones here. So hydrochloric acid. HBrAQ is hydrobromic acid. So notice the use of hydro, the replacement of the INE by ic, and then the use of the word acid at the end. Now, if you wanted to write the formula, here's how you would proceed. So I could give you a name for an acid. So let's say I give you the name, we'll type this one out, hydrosulfuric acid. But first of all, you need to realize that it's a binary acid. And the reason you know it's a binary acid is because you have the prefix hydro in the front. The other acids we'll see, oxyacids, do not have the prefix hydro, but binary acids do. So this is going to be a binary acid formed between hydrogen and, look at the root of the word here, sulfur. So all you do is do the crisscross between H and the non-metal that's going to be involved in forming this acid. So and crisscross as is. S has a charge of -2, H is a charge of +1, and we get H2 S. And don't forget that because we said that it's the acid, we have to put AQ. Now I know this is two nonmetals, and I told you that when you have nonmetals, covalent compounds, you should not do the crisscross. That rule still applies, except when you're dealing with acids. This is the only case where you can do the crisscross with a covalent compound. Don't make this a habit with other covalent compounds. You're specifically using it for the acid portion. Now I told you that when you are looking at formulas, you need to pay close attention to see if you have an acid or not. And usually the acid formula for binary acids starts with an H, but you can't approach this blindly. So for example, if I gave you H2O, you should know that this is not an acid. This is water. It's actually neutral. There is an H there, but this is not an acid. Okay. Similarly, if I gave you this, you usually don't see it written this way. But if I give you this, you should know it's not an acid. In fact, you usually see it written like this. This is ammonia, and it's actually not an acid, but a base. So don't approach this blindly. Look at it carefully. Don't call this hydroxylic acid. It's just water or dihydrogen monoxide if you're using the covalent compound naming system. Usually though, science refer to water by its common name. And typically for this one here, ammonia, scientists will call it ammonia. If you're using the covalent compound naming system, you'd say nitrogen trihydride. So again, binary acids start with an H, have a nonmetal that follow, have to have the AQ. If they don't have the AQ, you're not going to use the acid naming system. What you're going to do is you're going to just call them as you see the elements in the formula. So here we have hydrogen fluoride. Modify the ending of the second element, not the first one. So hydrogen is not going to be modified, just the second element, so the nonmetal. Here we have hydrogen bromide. If you don't put the AQ when we ask you to name the acid, it is considered incorrect. In the next video, we're going to take a look at oxyacids. I'll just give you a brief introduction to oxyacids, and we'll focus on them just in the following video. So oxyacids, they also start with an H. But rather than have only two elements in them, H and a nonmetal, there'll be an H and a polyatomic ion containing oxygen. So for example, over here, we have H and a polyatomic ion. This would be called an oxyacid. Oxyacids still increase the concentration of H+ in solution. The difference lies mostly within the way we name them and the way we write their formulas. And so we'll see that in the next video.